Today, I'm going to show you how to make a terrain shader that renders really fast. Let's go. Alright, the main key to making a shader render very quickly is figuring out how to reduce the number of texture samples that it does. The main reason terrain shaders are expensive and render slowly is because they have several layers, and each layer has its own set of texture samples. So if we take a look at the shader that we've created so far in this series, by the way, we're in the middle of a series of videos. If you haven't seen the rest of the videos in this series, I put the link to the whole playlist down in the description. There may be some things that I don't explain completely in this video because I've already explained them in previous videos in this series. So here's the shader that we created, and you can see that we've got 4 layers, and each of these layers is doing 2 texture samples in order to describe the material in that layer. The layer that we made last week, this rotation layer here, is actually doing 5 texture samples in order to break up the tiling. So here in this shader we have 2, 4, 9, 11, 12. So we're doing 12 texture samples, and this is just a very basic terrain shader with only 4 layers. So we're sampling a lot of textures. So today I'm going to show you how to create a version of this shader that creates very similar results, but using only 6 texture samples. And in the performance testing I've done, this version that I'm going to show you renders about twice as fast. Now, the key to reducing the number of texture samples is to use a different kind of texture called an array texture. So let me show you how it's going to work. Here in Substance Designer, I've pulled up the textures that we're currently using in our shader. For each of the 4 layers, we have a color and smoothness texture and a normal occlusion and height texture. So we've got 8 textures total. And what we're going to do instead is this. Instead of color and smoothness, now I'm putting the height data in my alpha channel. So I have a color and height texture for each of my 4 layers. And then the other data, the normal, occlusion, and smoothness, I'm storing in an array texture. So I've taken those other 4 textures, and if we take a look here, you can see that I've combined those textures together. So here's my dry soil, my kind of rocky, mossy texture. This is my moss, and then this is kind of my rounded pebbles. You can see how I've put all 4 of these together into a single texture. Now, setting up array textures works a little bit differently depending on if you're using Unity or Unreal. In Unity, we'll create a texture, a single texture like this, and then we'll tell Unity that it's an array that's 2 rows and 2 columns. But in Unreal, we'll actually keep these textures as separate individual textures, and when we make our array, we'll just create a list of which textures are going into the array, and it'll do it for us. So there's a little bit more work, a little bit more setup in Unity here to create one texture that looks like this. But for Unreal, I'll just give it a list of the textures that I want to use. So the setup is just slightly different for making array textures, but the result is going to be the same. And you might be asking yourself, well, what is an array texture? And what it ends up being is a single texture that acts kind of like a stack of pancakes. So when I sample the texture in the shader, it's going to ask me which layer of this array do you want to sample from? And I'll pass in an index value that'll indicate if I want to sample 0, 1, 2, or 3 in terms of the layer. Now, the main downside to using an array texture is that you can't blend between the textures in the array. So when you sample, you only get one texture at a time. And so in order to get smooth transitions between the textures, we're going to use dithering. So our color and height data will be blended, but our normal occlusion and smoothness data will be dithered. But because we're using height blending on the terrain, the transition areas are fairly small and high contrast, so the dithering doesn't really show much, but I'll let you guys be the judge of the results we get at the end. All right, so let's go ahead and jump into Unity first, and I'll show you how to build this shader there. And then in just a minute, we'll switch over to Unreal and I'll show you the same thing. Okay, so here we are in Unity, and we're going to come here to our terrain shaders folder, and I'm just going to make a brand new terrain shader here. Shader graph URP terrain lit shader, and I'm going to call this 4 layers dithered. And now we've got a brand new shader to work with. So the first thing that I want to do is open up our blackboard and add just a couple of parameters. So we need to add 4 texture parameters for the 4 color textures that we're going to sample. So we're going to make a texture 2D, and we'll call this CH1. And now we can just copy and paste this. So we have CH2 and CH3 and CH4. And these are the 4 textures that we're going to sample. So we're going to go ahead and bring these in. And now we need to sample them. So I'm going to create 4 texture samplers. Actually, you know what? It'll probably be easiest if I just make one of these and then copy and paste it. So I'm going to bring in a sample texture 2D. And we'll pass in our color texture that we're sampling. And then we need to take the X, Y, and Z. So we'll add a swizzle here. And let's just call this RGB just to make it a little bit clearer. And we want to add a pack material node. So we're going to pass the color into there. And then the last thing that we need is our height. So we're going to get that from our alpha. So there's our pack material node with our color and our height. So our C and H texture here brings in color and height. And then we're just going to go ahead and duplicate these nodes for the other 3. So there's our second layer, our third layer, and our 4th layer, and we're bringing in color and height for each of our 4 layers. Okay, now if you'll remember, we said that we're going to do this whole 4-layer terrain shader with only 6 texture samples, and we've already used 4 of them for the color and the height, so we only have 2 left. One of them is going to be our mask texture, and the other one's going to be our array texture. The next thing that we need to do is blend these layers together. And so I'm going to use a node that's called blend 2 layers alpha. And by the way, if there are some of these subgraph nodes that you don't have, what you can do is come up here under Window, and in Unity 6.3 under Package Manager, and then select your shader graph package. And new in Unity 6.3, there's this set of sample content called terrain shaders, and it comes with a ton of assets that you can use for creating terrain shaders. So some of these subgraphs I'm using come directly from this package of sample content. And if we take a look here in the Create Node menu under Terrain, you can see that because I've imported that sample package, I have blends, components, layer blends, layer materials. There's a ton of content here that comes in from the samples that Unity provides. Okay, so we need to use this blend 2 layers alpha, and we're going to use that to blend material 1 with material 2. And then we need a mask, but we're going to do the mask in a second. So let's just go ahead and finish blending our layers. So we'll blend layer 1 and 2, and then we'll take the results of that and use that to blend layer 3. And then we'll take the result of that and use that to blend layer 4. So we'll pass our material out here and bring in our packed material from over here. And now we've blended our color and our height data. But for each of these blend 2 layers alpha nodes, we need to pass in this mask value here. And so that's what we're going to do next. We're going to create the mask. You know what? There are a couple of other things that we need to do. First thing that I want to do is create UV coordinates for these color textures. So let's go ahead and do that next. So we'll come down here to our terrain menu, and we'll use our terrain texture node. And we're going to bring in our terrain texture node, and we'll create a split texture transform node. And this will get the tiling and offset values that we need for our texture. So now we can add a tiling and offset node and connect up our tiling and connect up our offset. And now if we want to, we can add another parameter here that allows us to control the scale of our terrain. And so I'm just going to add another a multiply node here, and we'll create a UV scale node in our blackboard. And this is going to be a vector 2. And we'll just call it UV scale. And I'm going to give it a default value of 1 for now, but then we can change that. We can use that to scale our terrain material up and down. Okay, and then finally, I can just connect up the UV coordinates that we just calculated to each of our 4 color and height textures. And then we also need a sampler node here. So I'm going to add a sampler state node and connect that up to each of the 4 terrain texture samplers as well. And there is one thing that I want to point out here. If I want this to be as fast as possible, I'm going to set filtering to linear, and then I'm going to come over here to my graph inspector and make sure that this anisotropic filtering setting is set to none. But if I want it to look really beautiful, instead of linear, I can set this to trilinear, and I can set my anisotropic filtering to times 16, and that will give me the most beautiful results with a little bit of extra cost for that. Okay, let me just clean up the graph just a little bit. I'm going to organize things a little, and I want to see if we've missed anything here. The next thing that we need to do is pass in the masks for our blend 2 layers alpha nodes here. And in order to generate those masks, we want to use the height data that we're pulling from each of our 4 textures. And so I'm going to bring in a new node here called a height mask. And this height mask takes in the height data from 2 layers and also from a mask texture. And then it uses that height data from the 2 layers to modulate the mask and create a more detailed output mask. And so we're going to go ahead and use this. So we're getting height data from our alpha channel of each of our textures. So I'm going to go ahead and plug that in. And now the result of our height mask node, we can plug into our mask here for our blend 2 layers nodes. Okay, so I'm going to copy and paste this one. And we want the height data coming out of here to go into our next height mask. And then we're going to use the height for height 2. We're going to use our 3rd layer. Then we can use that as our blend 2 layers alpha mask there. And then we want to create one more here. And we're going to use our height data coming out of here. And then we're going to use our 4th layer height. and then plug that into our last mask. So for each of these, blend 2 layers alpha, we're altering the incoming mask to use the height data from the 2 layers that we're blending together. So we're changing that mask. So instead of just like smooth linear interpolation, we're actually using the height data from the layer itself to create the blending. And the last thing that we need to do is bring in our mask where we paint which layer to apply on the terrain. And so let's come over here and do that right here. We're going to bring in a terrain texture node. And this is the new node that Unity just provided for bringing in terrain data. And we're going to set the terrain texture to sample the layer masks. And so that will bring in our layer masks node. And then we need to use the sampler texture 2D to sample our mask. And for this, we can just use a very simple sampler state. We can set this to linear, and we can set it to clamp and pass that in just like this. Okay, now this node here is going to give us the mask that we can use to blend between our layers. So we want to take the green channel, and that's going to be the mask to blend between our first 2 layers, and we'll pass that into our height mask node there. Then we're going to take our blue channel and pass it into our second height mask, and then our alpha channel, and we'll pass that into our third mask. So I think we're all set up here. I think that's all we needed to do to create a shader that will blend the color for each of our 4 layers. And then the last thing that we can do here is just pass out our color as the base color for our shader. And that's it. So let's go ahead and take this shader and apply it to our terrain and see what we get. So I'm going to come down here to our shader that we just created. I'm going to right click on it and pick Create Material. And here's the material that we can then apply to our terrain. So here's our terrain. I'm going to come over here to the terrain settings, and I'm going to drag this material and drop it in. Okay, so I selected my terrain shader that we just created here, and I created a new material for it. And here's that material that I created. I also went ahead and assigned our textures. So here's our dry soil texture, and our rocky mossy texture, our mossy texture, and our pebbles texture. And then now I can select my terrain and go ahead and apply this material. And that's what our terrain currently looks like when it's only blending color textures. So there's no normal here, there's no occlusion or smoothness. It's only doing color. And in fact, if you wanted to get away with not using normal maps or smoothness, you could probably use this shader just like this, and it's only actually sampling 5 textures. It's sampling the 4 color textures, 1 for each layer, and then the last one that it's sampling is the mask to determine where each layer goes on the terrain. So this one is really, really cheap. But you don't get the detail that you normally would if your terrain had a normal map or smoothness maps, and those can be kind of important. So what I'm going to do now is show you how to make a terrain shader that only uses 1 more texture, but it's going to give you normal, smoothness, and occlusion with just 1 more texture sample. So let's go ahead and do that. So the way that this works is we're going to sample our array texture. And before I show you how to add that to our shader, let me show you the array texture here in Unity so that you can see how it's set up. So our array texture is called Array 2x2 NOS. And if we take a look at the settings over here, you can see we've got texture type set to default, and then texture shape set to 2D array. And then for columns and rows, I have 2 and 2 because I have 2 columns and 2 rows of textures. I've got the alpha source set to input texture alpha, and then I've got compression type set to high quality. And you can see here that there's this little slider, and this will allow me to see which slice of the array I'm currently looking at. So there are 4 slices here, 0, 1, 2, and 3, and I can scroll through these to see each of the 4 different textures in my array. So this is like giving it the index value. Okay, well, let's go ahead and take this array and sample it. I think I can just drag and drop it. Yeah, you can see when I drag and drop my array from my project window, it's created this node called sample texture 2D array. And this is just like a normal texture sample, except the main difference is it has this index input, which allows me to select which texture in the array I'm sampling. So I've got it set to 0. I can also set it to 1 or 2 or 3. And you can see that setting this index value here is the same as setting this value over here when I'm previewing the texture in my inspector. And so what I need to do is hook this up so that my array gets the correct index value so that it knows where to use the 4 different layers in the array stack. Okay, but before we do that, I want to go ahead and set this up so that we can unpack the data. And so there's this node that Unity provides called unpack NOS. And it's for exactly this case where I have normal, occlusion, and smoothness. I'm going to wire this in, and it's going to unpack my normal, my smoothness, and my occlusion for me. And then I can bring this over, and we'll go ahead and connect it up to the rest of the shader here. So what I want to do is create another pack material node. And here we can connect up our color and our height. And then coming out of our array texture, we can connect up our normal, our smoothness, and our occlusion. And now we've got all the values that we need to define our material. And then we can pass out our material here. The last thing that I want to do, I think, is a distance fade. I don't know if we're going to have time to talk about this distance fade today, but I'm going to go ahead and add it here anyway, because it'll also help me to unpack my nodes. So, and then I'm just going to hook up my color, my normal, my smoothness, and my ambient occlusion, and our material is all set. Okay, so the last step that we need to do is create this index value here, and we need to do that by taking the various pieces of information that we've created already and just kind of expanding on things. So what I'm going to do is come over here to our blackboard, and for each of these color textures, we need to tell it which array index to use. So I'm going to create a new float, and we're going to call this array index 1. And then I'm just going to copy and paste that. And we'll call this array index 2 and array index 3 and array index 4. And now we can just put these up here. We have our texture number 1, our texture number 2, our texture number 3, and our texture number 4. Okay, and then I'm going to default these so they just go 0, 1, 2, and 3. And now we need to combine these together. So let's create a combine node. And we'll bring in array index 1, array index 2, array index 3, and array index 4. And pass those into our combine. And now we need to tell it how big our array is. And so I'm going to add another, I'm going to add a vector 2 here. And this is going to be the number of rows and columns, kind of like we created over here when we defined our texture shape as an array. We're going to make the array width height value. And this is a vector 2. And we'll default this to being 2 rows and 2 columns. So this way we can use different size arrays if we want to. And so what I'm going to do is split this value out. And then we're going to multiply our rows times our columns. What we're trying to do here is figure out how many textures are in our array. And so if I say there are 2 rows and 2 columns, then we multiply that together. And that's going to give us a total number of 4 textures in our array. And so if we want that value to go from 0 to 3, the next thing that we need to do is subtract 1 so that now we get the total number of textures minus 1, which is going to give us 0, 1, 2, or 3. So now I can divide this index value that I've passed in by the total number of frames, just like that. Okay, now the next thing that we need to do is set up our height-based dithering. And so I'm going to create a new combine node here. And we're going to grab the results that we've got from our height masks here. And I'm going to plug these into the green channel, the blue channel, and the alpha channel. And just like we use these height mask nodes up here to blend our color, we're also going to use them to blend the sampling that we're doing for our array texture. Now, there's one thing that's really interesting. I'm going to create a dither node here. And you would think that I could just pass my height maps directly into my dither. But one thing that I've noticed about this dither node is for some reason it needs a range of 0 to 2 instead of a range of 0 to 1. And so I'm going to add a node here to multiply my incoming data by 2 before I pass it into dither. And now that I've passed it into dither, what it's doing is it's taking the height data and creating dither masks that are just like 1 bit. It's either on or off. And that's going to allow me to do a smooth blend with my array texture, even though I can only sample 1 texture at a time. Now I'll finish off this portion of the shader just by adding a saturate node to make sure the results of my dither are either 0 or 1. And now I can take that saturate and multiply it here by the masks that I'm creating to create my final value for my array texture. Now, right now, I've got a mask for each of the 4 layers, and I need to take the output here and split it out, and then blend between each of the 4 masks. And so what I'm going to do is create a lerp node and blend between my red channel and my green channel. And then I'm going to blend between that and my blue channel. And then I'm going to blend between that and my alpha channel. And for the blending, I need to take the dither masks that I created here. So I'm going to split those out again. And we're going to use the green channel, the blue channel, and the alpha channel. And so basically what we're doing here is creating 1 dithered mask with values that are either 0, 1, 2, or 3. Right now they're between 0 and 1, but I need to take this as the very last step. I'm going to multiply this by the number of textures in my array. and we'll pass that in. And then this value here becomes the index for my my sample texture 2D array. So I'm going to pass that into my index. And this is going to give me my dithered array texture. Okay, I think I need some UV coordinates here as well. So I'm just going to grab the same UV coordinates that I created for my color texture. I'm just going to grab those and pass them into my array sampler. And I think we're all set. I think that our shader is done. Oh, one last thing here. We're going to need to use a sampler on our sample texture 2D array. And I can use the same sampler here that I used for my 4 color textures. Okay, let's save this and switch over and see what we get. Okay, this is looking pretty cool. We can come down here, and if we zoom in really close, I don't know if this is going to show up on YouTube or not, but you can see that the dithering is allowing us to take that texture, that array texture, and blend, and it's giving us some nice smooth blending with just a little bit of dithering artifacts here and there between our layers. Let's take a look. If we come here under Window and go to Analysis, Rendering Debugger, let's go to Material, and let's take a look at our different material components. So here's our albedo. You can see that it's doing a really nice job of smoothly blending our color. If we take a look at our smoothness, now this is where the dithering shows up. Can you guys see this dithering pattern that's happening? This is because we're using our array texture, and we can only sample one texture or the other. We can't sample both and blend smoothly between them, and that's what we're using that dithering node to do. So it shows up here, but it doesn't show up quite so much when we're doing it this way. And again, our normals are going to be the same. So we got this dithering, but maybe we can't really even tell. There's a little bit of a pattern there, a little bit of dithering pattern, but because we're rendering at high resolution, I don't know if you can even see that. Now this is giving us color, normal, smoothness, height, and occlusion, but it's only doing 6 texture samples. And again, in my tests that I've done, this renders about twice as fast as the standard way of not using a texture array. Okay, so this is our whole shader. I think maybe next week I'll talk about this distance fade node. I didn't really have time to go over that today, but it is kind of an important topic that I want to get to. But what I wanted to show you is that we're able to sample just 6 textures and get 4 full layers of color, normal, occlusion, height, and smoothness because we're able to pack all that data into a single array texture. So hopefully this is helpful for you and that you can kind of get an idea for how you can use array textures to really speed up your rendering. There are a couple of downsides. One of them is that we're dithering, and so you do get these dithering artifacts like this. The other downside is that we can't scale our materials independently. So I couldn't make our dirt tile more or less because they're all packed into that one array texture. We have to have one uniform scale value. So I can scale the whole thing uniformly like this. So we can make this smaller, or we can make it bigger. You know, if I set it to 0.25. So we can scale the whole thing, but we can't scale the individual layers by themselves. And so what you'd want to do is set up your 4 materials so that their scales were all the same. Now, last week we talked about tile breakup, and I talked about how you wanted to make the scales different so that you could use each individual layer to break up the scaling on the other 3. And we can't actually do that with this technique because all 3 of them have to be exact, or all 4 of them have to be exactly the same. And so you may end up with a little bit more tiling with this kind of technique, in which case you'd want to see if you could hide the tiling in other ways, like not making really big areas of just one material like this, you know, or maybe covering up specific spots in the terrain with rocks or with other scattered details like little bushes and grass and that sort of thing. Okay, but that is my tutorial for creating an array texture-based terrain. Let's go ahead and switch over to Unreal, and I'll show you how to do the same thing there. All right, here we are in Unreal, and just like we did in Unity, we're going to build a terrain shader that has 4 layers, but only does 6 total texture samples. So the first thing that I want to do is show you how we have our textures set up, and then we'll jump into building the shader. So here we have 4 color textures, and they have the color in the RGB, and then they have the height data in the alpha channel. So the alpha channel looks something like this. This is the how high each of the pixels is in the data. So we have our 4 color textures, and then the other set of textures we have are our NOR textures, so normal, occlusion, and roughness. And those look like this. They have the normal in the X and the Y. They have the occlusion in the blue channel, and then they have the roughness in the alpha channel. So this is what that looks like. Red, green, blue, and alpha. And I did bring these over from what I was using in Unity. And so in order to make that work, I had to check this flip green channel box so that my normal data would work, because Unreal has its data in the Y. The Y component of the normal looks like it's being lit from underneath, and it's the inverse in Unity, so I had to flip my green channel. You can either do that in the texture itself, or you can just do it here in the settings. So I brought in each of my 4 NOR textures, and then I combined them together to create an array texture. And just so you can see how that works, I want to show you how to create an array texture here. You right click and you come down here to textures, and then you pick texture 2D array. And that's going to create a texture that's very similar to other textures with one key difference. If I take my settings here and scroll down to the bottom, there's this section called source textures, and this is an array. And what I've done is combined those 4 NOR textures that I made into one single array texture. And it ends up looking like this. It looks like a stack of textures. And it doesn't actually look like this in the results. It's just showing these stripes of the 4 textures that are in the array so that you can tell, oh, this texture has 4 textures in a stack in it. The real texture doesn't actually have, well, it has 4 textures stacked, but they don't actually look like this. It's just using this as a visual representation. And if I want to see what it actually looks like, if I check this slice box here, now I can, just like I was doing in Unity a minute ago, I can tell it which slice I want to preview and see which texture is in each of these slice slots. So I can look at slice 0, slice 1, slice 2, and slice 3. If I have slice unchecked, it's going to show that I have 4 textures in the array. All right, so now we just need to create a shader. So I'm going to come over here to our shaders folder, and we'll right click and pick material. And I'm going to call this 4-layer dither. And we'll open this up and get started. So the first thing that I'm going to do is bring in my 4 textures. And I've already got these in an off-screen shader that I'm working with. So I'm just going to paste these in here. You can see I've got my dry soil, my rocky moss, my moss, and then my kind of round pebbles. And for each of these texture objects that I brought in, I need to create a texture sample. So we're going to create a texture sample node and wire our texture object into our texture sample. Now, if I wanted to, I'm not doing it in this case, but if I wanted to, I could expose each of these texture objects as a parameter, which would then allow me to put different kinds of textures into my shader. I'm just going to make a hard-coded one for now, but you can make yours a little bit more flexible so that it'll allow you to put different textures into those texture object slots. All right, so I've got a sampler for each of my objects. The next thing that I need to do is set up some UV coordinates. And for coordinates, I'm going to use the world position node. And we're going to use the X and the Y because this is a top-down projection. And then I'm going to add a divide node here. And I'm just going to hold down 1, and I'm going to add a value of 200. This represents 200 centimeters. And so what I'm saying here is that each of my textures is going to take up the space of 200 by 200 centimeters. So I can use these as my UV coordinates, and I'm just going to wire them into each of my 4 texture samples. All right, there we go. And then the next thing that I need to do is blend between my samples. And so I'm going to add lerp nodes here. And we're going to lerp between the RGB of my first texture and the RGB of my second texture. And the way that we're going to do this lerp, we need to use height-based blending. And so I need to create a new node that's called height mask. And I've already created this node. Actually, let me go ahead and create the rest of these lerps here. So I'm going to lerp between the result of that one and the third one. And then I'm going to lerp between that and the fourth texture here. And we're going to set up our height-based blending. So I can add in a node that's called height mask. And it looks like I haven't added it to the menu yet. So I'm just going to grab it from my content drawer here. This height mask node. This is going to take the height data from my original, from my 2 materials, and use it to create a mask that I can use for blending. All right, now before we go on, it's really important for me to show you what's in that height mask material function that I've been using. So here in my content drawer, you can see that I've created this new material function called height mask. And that material function looks like this. I have 2 inputs, height 1 and height 2. And you can see for each of those, I've checked this use preview value as default. And then I've given them a preview value of 0. So, and then I have my third input, which is for the mask. And that's also using a value of 0. So I take my mask, subtract 5, and multiply by -1. And then I take my height 1 and add those values to it. And I do the same thing for my height 2. And then I subtract my height 1 from my height 2. And then I multiply by 4 and add 0.5. So this multiply by 4 is for the contrast. So you can increase or decrease the amount of contrast in your height blending by adjusting this value, this hard code. It's just a hard coded value of 4, but you can increase it or decrease it to change the amount of contrast. So then I add 0.5, saturate the result, and then pass it out. And so basically I'm using the 2 texture height data inputs plus the layer blend mask to create height-based blending. And it's pretty simple. There's just a little bit of math involved. And this material function, then I can plug that into the rest of my landscape shader to get height-based blending between my layers. And so what I need to do is plug in my alpha channel here, which is where my height data is stored, from my first texture and my second texture.
And then I'm going to use that as my mask for blending. So let's move these lerps over just to give us a little more space. And we're going to plug our height mask into our alpha channel that we're then going to use to blend our materials. So the last thing that we need is an input for our height mask here. And this is going to be the mask for our individual material layers. And so I need to create a node here that's called landscape layer weight. Let me find that one. Landscape layer weight. So this node is going to bring in the layer weight for each of my individual layers. But I need to make sure that I get the name right here. So I need to tell it which layer to use. This layer here, my second layer, is going to be called mossy ground. And so I'm just going to come over here and type mossy ground. And if you're wondering what names to use for your landscape layer weight node here, whoops, I put it in the wrong place. Ground. If you're wondering where to get those names, let's switch back over to our scene here. I'm going to select my landscape, and I'm going to switch into landscape mode. And that's going to bring this panel up over here on the left. I'll switch into paint mode, and you can see here each of my terrain layers has a name. And I gave it those names previously when I created the layers. And so if I want to bring the mask into my shader, I just need to use the same name that I'm using on each of these layers here. So if we switch back to our shader, you can see I used mossy ground for that one. That's going to bring in the mask for my second layer. And I'm just going to plug that into my height mask. Just like that. And then here for my next layer, I'm going to clone my height mask. I'm going to grab the height coming out of here. I need to create a component mask for the alpha channel coming out. And I'm going to use that for my first height. And then my second height coming in here is going to come from my third layer, like that. I'm going to plug that into my alpha. And for my layer mask here, I need to grab my moist stone layer. So I'll type moist stone and pass that into my mask there. And then I need to do the same thing for my final one. So I'm going to plug in my alpha channel, my mask, and this mask is called River Stone. You may have different names depending on how you have your landscape set up. Oh, and then the last thing that I need to do is grab my alpha channel coming out of here with a component mask. I want to grab the alpha channel and plug that in for height number 1. So just a quick review here. For each of these layers, we're using the height data from the sample to blend between the first layer and the second layer, to blend between the second and third, and then to blend between the third and the fourth. And so my result is going to be color coming out, and I can plug that color into my base color there, and that's going to give me a shader that just blends color using height. So let's go ahead and assign this shader to our terrain and see what we get. And it's not working, so we need to take a look at our shader and see what we did wrong. I think I know what it is. I think, so these landscape layer weight nodes that I added, you have to tell it to use a base or a layer, and I need to give it a value of 1 in this layer input. So I'm just going to hold down the 1 key and click and give myself a hard-coded value of 1, and I just need to plug that into each of these layer inputs. And once I've told each of these that they need a value of 1, I can save this, and it should work now. So I'll switch back to my level. Yeah, so now it's working. So if we fly around here, you can see that we're blending between our 3 different color layers based on that height. Now, we don't have any normal or roughness or occlusion data in here. We just have color. And so the terrain actually ends up looking kind of flat. But that's okay. Now, if you wanted to make like the absolute cheapest version of a terrain shader, you could use this shader just as it is. You know, we're only doing a couple of texture samples here. We don't have any normals or roughness or occlusion, but this is a very cheap way of doing a terrain shader. We've used like the absolute bare minimum of texture samples. But if you're able to use just one more texture sample, what I'm going to show you next is how to use the height or the array texture that we created, this array texture here, to get our normal, our occlusion, and our roughness, all of that data for all 4 layers with just one additional texture sample. So let's do that next. The first thing that we need to do is bring in our array texture. So I can just drag and drop that in here. And that's going to give us a texture sample. Now you may be thinking, this texture sample looks exactly like my other texture samples. How do I specify which layer to sample here? You know, because I've got my 4 different layers all packed into one texture. And the way that you do that is with the UV coordinates. So I'm going to add an append vector node. And this UV coordinate that I'm passing in, for the first part of it, I need my standard UVs that I'm using here for my other textures. So I can drag that into my append. But then the second part of it is going to be the index value that specifies which layer or which level of my array to sample. And so most of what we're going to be doing for this next part of the tutorial is creating the portion of the shader here that's going to tell it which part of the array to sample. But first, well, let's go ahead and unpack the data coming out of our array. We're just going to create an append vector node. I'm going to assemble my normal from the red and green channels. And then to unpack the normal data, we need to multiply by 2 and subtract 1. So we're going to take the red and green channel, multiply by 2, subtract 1. And then for, just like we have in the past, to save on a little bit of calculation, instead of computing the Z component, we're just going to give it a hard-coded Z component of 0.5 and call it good. Now, if you wanted to, you could compute the Z component and get a little bit more accurate results. But in my experience, for terrain materials, it's okay to just do it this way. So we're going to wire this into our normal output. And then we're going to take our blue channel and we're going to wire that into our ambient occlusion. And then we're going to take our roughness from the alpha channel and wire that into our roughness. So now we have a shader that is giving us color, roughness, normal, and ambient occlusion. And it's doing height-based blending. But in order to handle our array correctly, you can see I'm getting an error here. And that's because I haven't passed anything into my append B input socket. And that's where we actually need to calculate which values of the array we need to use. And so in order to do that, I'm going to come over here, hold down 1 and click. And this is just going to give me a hard-coded value. This hard-coded value represents the number of textures in the array. And I could expose this as a parameter if I wanted to make this a flexible shader and support, multiple different sizes of array. But for now, I'm just going to give it a value of 4. And I need to subtract 1 because I need this range to go from 0 to 3. So I'm going to subtract 1. And now I need to give it some values that represent the index values of my 4 different array layers. And so for my index values, I'm going to give it a value of 0, 1, 2, and 3. So I have my vector 4 here with 0, 1, 2, and 3 coming out of the red, green, blue, and alpha channels. And I'm going to divide these values by the total number of values in my array. And now I'm going to multiply by my height data. In order to create correct height data, I need to come up here to my height masks, and I need to create some dithering based on each of these masks. So I'm going to use a node that's called dither temporal anti-aliasing, and I'm going to bring the data coming out of my height mask and plug it into the alpha threshold for my dither temporal anti-aliasing. So what this is doing is it's taking the 2 height textures from my color textures. It's taking the 2 bits of height data, coming up with a final height, and then instead of a nice gradient, I'm translating that to a dither using this dither temporal AA node. And I need to do that for each of my 3 height masks here. I'm going to create 3 copies of this dither temporal anti-aliasing. And I need to wire in my height mask that I've calculated for each of these here in order to bring these down here. And I'm going to use an append many node to combine all of these together. I'm going to put this one in green, blue, and alpha. And then we're going to take the RGB value here and saturate it. And then we're going to multiply our result up here by the result that we got down here. So we're taking our channel values and multiplying them by our 3 different dither masks. And then we need to break out our result. So I'm going to use a breakout float 4 components. And now we need to use lerps to blend between each of our masks. So I'm going to take our red and our green, and we're going to lerp between the 2 values there based on our first dither mask here. And then we're going to lerp between that and our blue channel based on our second dither mask here. And then we're going to lerp between... Oh, I got an inverse lerp there. I need a linear interpolate. We're going to lerp between the result of that and our blue channel based on our second dither mask. And then we're going to add a third lerp. So we're going to lerp between our results and our alpha channel based on our third dither mask. Okay, so that is going to give me the value that I need to pass into my append node, except right now these values are between 0 and 1, and I need them to be between 0 and 3. And so I'm going to multiply this result here by my value that I created for over here for how many layers there are in my array. Okay, and that should do it for my my shader. Basically, I've packed all of my normal occlusion and roughness data into the array, and I'm using these nodes here to determine which slice of that array to sample. And then once I've sampled it, I unpack my normal and grab my occlusion and grab my roughness and plug them in here at the end, and I'm all set. So what this is allowing me to do is have 4 different layers on my terrain and blend between them using height blending, but reduce the total number of samples that I'm making. Instead of doing 2 samples per layer, I'm just doing 1 sample per layer plus 1 additional sample for my array, and I'm getting all of the rest of the data from that array. So it's pretty cool. So we'll go ahead and save this, and we'll switch back to our terrain. And now you can see my terrain is significantly more detailed. Before it looked really flat, but now that I've got that nice normal mapping data, the occlusion and roughness here, I'm able to get much nicer looking terrain, much more detailed, and it only took 1 additional texture sample. So this is a really cool technique. It allows you to get a lot of detail on your terrain, to add multiple terrain layers, and then to minimize the number of texture samples you're doing in order to render that terrain. Pretty neat. And like I said, in the tests that I've done, this renders about twice as fast as the standard method. So I hope you enjoyed today's video. Let me know down in the comments if you have any questions or if things weren't very clear. And I look forward to seeing you all again next week, where we're going to continue our journey learning how to create terrain and landscape shaders in Unreal and Unity. All right, have a great week, everybody.